Good afternoon, my YouTube viewers. In this video, we're going to perform another hypothesis test, and this hypothesis test is going to be a binomial hypothesis test. So a school claims that 80% of its students pass the final math exam each year. This year, a random sample of 40 students was selected, and 28% of them passed. What is the statistical evidence at the 5% level to suggest that the true pass rate is lower than the school's claim? So the first thing we're going to do is we're going to say the claim proportion is 80% and the sample size is 40. The observed proportion is 28%. So the observed successes is 11. Because let's say, let me get my calculator out. It's a little bit dark, but 28, so 28%. Let me get my calculator. So we're going to say so 40 times 0.28 equals 11.2. So we're going to say that's how you get your 11 observed successes. But what we can do is we can say equals int to make it more Excel-ish. And that's going to make it. But if we really want it to be good, we can come over here to to round the number down, you say round down number of digits. Because int is just going to I'm going to try 0, see what happens. So there you go. So what we do is we round it down because the observed success is, I don't know, I think that you'd round it down to the observed successes because that's just what I think that you would do. But you could do round, try round. That would make it 11. So we'll round it. And rather than round down, we'll just round it. Okay? And then your significance level is 5%. So your standard error is the square root of the claim proportion being 80% times 1 minus 80%. So that's 20% divided by sample size 40. So that's going to be your standard error. Your z-score is B9 minus B7. So that's the observed proportion minus the claim proportion divided by B12. That's your standard error. So that's your z-score. And your p-value is norm.s.dis. So it's a normal distribution. Brackets B13 is your z-score. And then true. And so that's going to give you a really low p-value. And then if it's a really low p-value, less than 0.05, phi, then you know you're going to reject the null hypothesis. So the null hypothesis is the observed proportion is similar to the claimed proportion, and the alternate hypothesis is the observed proportion is not the same as the claimed proportion. And then so what we're going to do is we're going to interpret it. You can say if B14, that's your p-value, is greater than or equal to B11, that's 0.05. You're going to say fail to reject the null hypothesis. Otherwise, you're going to reject the null hypothesis. So we're going to reject the null hypothesis in favor of the alternate hypothesis. So that means the observed proportion is not the same as the claimed proportion. And I've also made an exam pass rate. So your claim proportion is 80% and your exam proportion is 27.25%, which is rounded up to 28%. So that concludes this video. The next video is going to be a hypothesis test on the Bernoulli distribution, and I hope you decide to watch it.